Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. We are focusing on the 28 days to phi journey today, day 16, wrap. We want to create something by the end of today's lesson that we can put in our pockets and wrap objects in nature up in to see, could this be like the Pyramid of Giza in Egypt? Because I know the Pyramid of Giza was built in relation to phi. So if I have something in my pocket that I can wrap maybe objects like a pine cone up with to determine, could this be three-dimensionally a representation of phi? Then I'm elevating my naturalist hiking kit to another level. As of right now, I have things like a tape measure in my naturalist kit, pen, paper, my iPhone, okay, wherever that may be. My iPhone is a great tool to have in my naturalist kit to take pictures. I recommend the iNaturalist app for those of you going out into nature and looking at something and not sure what it is, especially if it's really, really big and you can't bring it into your home like this. So day 16, we're going to wrap for phi. No, I'm not going to rap for you today. Maybe if I get super excited later, I'll freestyle something. I've never done that before in my life, but wouldn't that be fun? So, if you look at the PDF enhancement, let me pull my face over to the side. You will see that we need to think about wrapping, right? So how do you wrap a present? How can we wrap up this project? How can we wrap our heads around phi? So if you look at my website, you'll see the PDF enhancement. I also believe that it's linked below. Okay, if you pull that up, you might lose some space on your computer screen, so you might want to grab another device to look at it. If you have a printer, go ahead and print it if you're allowed to. Some materials that you want to have today to be successful. Piece of paper. So yesterday we made, a quick net of phi in terms of what a scale model of the Pyramid of Giza might look like. Today we're going to do one that's much more precise that you can add to your toolkit that you can take out into nature. Today on Cape Cod, it's about 35 degrees. It's not super nice out, not a day where I'm going to be spending hours on the hiking trails. So these are good days to, come inside, wrap up in a blanket, get comfortable, and prepare your toolkits so that the next day you can go out on a hike. You have all the scientific and mathematical materials you need to be a good mathematician and analysis of nature. So I have tape. And if you don't have these materials, don't sweat it. Remember, you can be creative and sort of make something of your own using duct tape, any sort of tape that you might have around the house. So I have tape, paper, something to write with, and I did bring scissors to class today because I want to make a precise net of the Pyramid of Giza, and then I can take that into nature and wrap it around nature objects to see if my objects are growing in relation to phi three-dimensionally. So those are some things you might want to grab. So I want to give everyone a couple moments to grab scissors, something to write with, tape, paper, a smile, okay? And we want to talk more about surface area, volume, and what a formula is today on day 16, 28 days to phi. By the end of our session today, we want to understand how can I make a model of the Great Pyramid of Giza using the golden ratio, and furthermore, use it as a tool to measure objects in nature. And you might be saying, what do you mean measure objects in nature with a net? Well, what I'm saying is if I made a net and then I covered it in tape and it was pretty durable, okay, and I knew that this was a scale model, proportional, it's proportional to the ancient Egyptians' Great Pyramid of Giza, and I know that this is built with phi and the square root of phi and a unit, right? So I also know that from here to here, that with my unit circle that I'm considering that to be 1 unit, right? And we know that phi is 1.618, so it's about 60%, so 60%. This is a great phi tool to take into nature, is my point. Okay, you could also wrap up objects in it and say, how well does that fit inside? Thinking more about the volume of it. So yes, we're talking about surface area, volume, and some formulas to create a tool that we can put in our naturalist toolkit when we go on hikes and explore nature and be able to look at nature with a mathematical lens. Remember, this journey is a whole new experience for all of us. We're all at home creating space for a daily practice for math. You are worth it. When you make time for math, you're showing up for yourself. You are putting your self-care first. You are learning. Okay, so 1, you have to show up. 2, you have to change your perspective. 3, get out into nature. Nature lowers our cortisol levels, our stress hormone. It allows us to be more restorative, more open to learning. So get out in nature to help you, especially when you're struggling with math. Recognize when you're struggling and embrace it as a learning moment. Turn back when you're frustrated. Speed up when you're bored. Okay, so all right, that's our first 5 minutes I like to give to everyone so that they can get comfortable, get what they need, and get ready for the day. Okay, so our second understand question is, how did the Egyptians communicate mathematically? And that's just something, if we get to it, thinking about, wow, so many centuries ago, humans, much like us, but much different from us, were using a base 10 number system. And how did they communicate mathematically? They didn't have our numbers. They had hieroglyphics. So maybe we'll get into that, maybe not. But to activate today, okay, I want you to just think about this picture. It's me on my hiking trail with my daughter, just loving looking at the trees this time of year. They're just breaking out in fractals. It's so soothing to my mind and my heart to see all of these fractals everywhere, and most of them probably are growing in relation to the golden ratio. So the questions for the activator are, how many branches do you see? Wow. This is a great example of no right answer. Okay, if you said 1 branch, that would be wrong, because well, maybe not. Maybe you interpret it as, how many branches do you see Sam touching? And sure, that might be 1, right? So however you see this picture and you can justify an answer that makes sense to you, you want to be able to reason. So if you're with someone, I want one of you to be a skeptic, which means one of you is going to doubt the other, right? Respectfully, openly, and free from judgment, but you're going to challenge their point of view. You're going to challenge their ability to argue. Okay? If not, if you don't have someone, grab a mirror or grab your phone and argue against yourself. Be silly. Communication is such a huge component of math that we need to cultivate and work towards, especially when we are not surrounded in our peers like we would typically in a school setting. So talk about this. How many branches do you see? If you're the skeptic, ask good skeptic questions like, well, how do you define a branch? What strategies are you using to estimate that? Did you have to count any of those? What section of the picture did you count? How did you account for the perspective of the landscape versus foreground and background? Obviously, the branches in the background are way teeny tinier. How are you estimating those differently from the ones up close? Are you defining a section of the picture that you're counting the branches? Are you only using the ones that Sam's touching? Are you only using the ones that are sticking out horizontally with a 0 rate of change? You can continue on thinking and talking about how many branches do you see. Please comment on muddymath.com, day 16. Okay, what is your idea? How many branches do you see? Or if you want to change gears, how has nature impacted your learning? You've heard me talk about the fact that nature lowers our cortisol levels. So how has that impacted your learning, especially with math, or your relationship with math? Go ahead and talk about that with someone near you. Look at my flyaways. Or comment on muddymath.com. How has nature impacted your learning? I know that This morning when I walked my dogs, I was just overwhelmed with the gray sky and the contrast of all the branches before they're budding. So on Cape Cod, they're budding. They have these little tiny nodules at the end of their branches. They're budding, and it's beautiful, nice contrast against the sky, and I get to see all these fractal patterns in the morning. It's very soothing to me. It's a nice way to smile and breathe in the fresh air. Okay? So that's a quick activator. Just an invitation for you to look at something that's just a typical picture with a mathematical lens. And the more you do that, the more math will infuse into what's organic and natural for you. And you'll be surprised at how practicing math every day brings less stress to your life, more community, less aggression, and maybe more smiles. So I hope you're activated, you're warmed up. I'm really curious to hear how many branches you counted in the photo. So please comment on muddymath.com day 16. How many branches do you see in the photo? And compare and contrast your answers to others who are following along on the journey with you. So without further ado, let us talk about surface area. So surface area is, if we were to calculate the area of our net from yesterday, that is the surface area of the Pyramid of Giza. So before we start calculating the surface area of the Pyramid of Giza, do you think that the Egyptians would have actually needed to know the surface area, the number of square units needed to fill the surface of a 3D solid? Do you think they would need to know that? What are some reasons that the Egyptians might want to know the surface area of their pyramid? Would they need to know the area of the base of the pyramid in addition to the faces? Right? These are our faces. These are what are exposed to the sun. Would the Egyptians need to know that plus the bottom? I mean, if this was a present, we would and wanted to wrap it or paint it more, because wrapping paper is, we just fold it up, and who's cutting your wrapping paper like a perfect net? Nobody. I don't know anybody that does that. But what if painting? Say that you had an object, a pyramid, and look, I borrowed my baby's pyramids. Okay, so what if we wanted to paint this? And it was super ginormous. This is just the model of the pyramid we wanted to paint, and we needed to know how much paint we needed to cover it. At least an estimate, and then maybe get a little bit more than that estimate so we have enough paint to paint our project. Okay, that would be surface area. We would want to know the surface area, because often paint products will tell you this bottle will cover about blank square feet or blank square meters, right? So surface area. So what I want you to try to do is draw the net of a pyramid. We created a net yesterday. I'm going to show you how to draw it again as a review. Determine the surface area. We'll estimate just to save time. And then we want to try this on 1, an isometric grid, and 2, a coordinate plane, and see what the benefits are of graphing it on an isometric graph versus a coordinate graph. Okay, and honestly, looking at the time, that might be a challenge I leave to you. So I'll show you how to do it with the coordinate graph, the rectangular one on the right-hand side of your screen. And maybe if you have more time today, you can try it again on the isometric graph and see what the benefits are of the isometric grid versus the rectangular grid. So let's go ahead and pull my video camera to the front. Hey! And I will show you how to draw a net again of our Great Pyramid of Giza. So you want to have a piece of paper ready. If you have graph paper, great, grab it. I'm going to show you how to do it without graph paper. This is the negative space of our net from yesterday, and I can use this as a guide, right? So the beauty of this sketchy, it's not like precise or anything, is that it gives us some guidelines. So I first need to define what 1 is. So how, like I showed you guys before, if we're doing something, you can define 1 by maybe the length of your fingers. But if you have a beautiful tool like I do, okay, I might just define 1 as the distance between these 2 red points, because that's easy enough for me, okay? Or I can pick an actual number and do 10 centimeters. Why don't I just do 10 centimeters? I love the base 10 system. So I need to draw a square with 10 centimeters. Go ahead and try it, okay? You're going to try too. So what's important about a square is that they meet at right angles. And what I really want you to do today is not erase too much. I don't want you to erase too much because I just want you to go with it. Go with the flow. Trust me. Trust yourself. Trust that things aren't going to be perfect, and when you make mistakes, it's a learning moment and not a moment to get upset or anything. Okay, and remember our estimate of phi, here we go, back to week 1, our rational approximation of the ratio phi is 1.618. And phi is a ratio, so we're thinking about it as 1.618 to 1. Okay, and the beautiful thing about phi is that the sum of the two distances compared to the longer distance is equal to the longer distance compared to 0.618. Right? That's the fascinating relationship of phi. So we're going to use this to help us build our pyramid net. We know that from the center, if there was a circle in the middle of that square, from the center to one of the sides in a perpendicular line, right, from here to here, that is equal to 1. Okay, so we created a square so that the center has a radius 1 if there was a circle inscribed inside the square. So inscribing a circle into a square means it's like the biggest circle that'll fit into that square, and it touches 4 points on the square. They share those points, and connecting those points, that shows us the radius 1. Okay? Now, I hope you have your square. Okay, in my drawing, let me zoom in. Soon I'll actually have a zoom feature, but right now we'll just move the whiteboard. Okay, so if that's 1, then that length is 2. And remember, I chose to make that length equal to 10 centimeters on my ruler. So my scale here is that 2 units equals 10 centimeters. And then the scale for 1 unit is equal to 5 centimeters because they're proportional. So this goes back to scale drawings, proportionality, so much of what we've been learning already on this adventure, and we're applying it to yet another perspective, connecting the neural pathways. We are amazing. We're showing up every day, carving out time for math. Okay, my little side notes are just to give you time to catch up. So now we need to create the 4 triangles that will break off of the base. This is the big base, capital B base, the base of the pyramid. Okay, so that's different than the base of the triangle. Now, the base of the triangle of each of the faces, let me say this again slowly. The base of the triangle for each of the faces, so each face is a triangle. The base of the triangle is the same as the side of the square base. So the square base has a side. That side is the same 4 ways around, okay? And that is equal to the base, the lowercase b base, oh, you guys can't even really see that. Lowercase b base, and of the triangle, of the face, of the triangle face. You see that? So this is the lowercase b base of the triangle face, the lowercase b base of the triangle face. There you guys go, my first rap ever. Okay, on day 16, rap here with Sam, Miss Flynn, Muddy Math. Oh, no, I'm just kidding. All right. Smile, people. Why not? Why not smile? Okay, and then the side of the square. These are the same length. It's the same measurement. So straight up, okay, from that center point, right, there's the radius 1. I'm going to form another right angle with the line segment I'm about to draw, and that'll be the height of the triangle face, which is called the slant height of the pyramid. So many words, right? Just get past the words, or, if you like words, stick with the words. If you like pictures, stick with the pictures. I don't know what to tell you. All right, I'm just kidding. I do know what to tell you. Follow your heart. Find the struggle. Push through it. Avoid the frustration. Avoid the boredom. Miss Lynn's a broken record. What does she keep talking about? Okay, so we know that the height of the face has to be phi. So if the base is 1, okay, phi is a ratio. So what are we comparing it to? We're comparing it to the unit. So the base is, 2 units. So if this is 1 unit, okay, then I know that phi is going to be 1.6. So the base is the 1 unit. Here, let's color code. Oh, color coding. I haven't been doing enough of color coding on this channel. My classic muddy math followers with my gray whiteboard, colors were tough. But now I got this whiteboard and beautiful markers. Let's use them. Okay, so the base is the 1. So 1.618, okay, is going to be the height. That's the ratio. The height of the triangle to the base. Now, if the base is 2, right, then we want half the base to find 1. Our unit of measure is the radius of the circle that was inscribed. So we have 1 here. Now, I could use my fingers, and this is something you guys can do if you don't have a cool compass like I do, okay? And you can even, like if you have chalk, you can see the arc go through it. If you have a whiteboard at your house, then you can see the arc go through it, okay? But that's the arc of a circle radius 1. So if I go up to there, then I've made a triangle with a base 1, base 1. But I don't want that. I want the height to be 1.618. So if 5 centimeters is equal to 1, then I want to know what is 1.618 in centimeters. Proportionality, rules, middle school, proportionality. So proportions are the key component, I think, to middle school. It's everywhere in middle school math, and before and after, right? So even if you're a kindergartner, okay, proportionality is just making sure if you draw yourself or you draw mommy or daddy, like one eye isn't 10 times bigger than the other. But if you're being imaginative and creative, then do disproportionality. I digress, okay? So we're taking our time really trying to understand this net of the Pyramid of Giza so that you guys can make a really precise net and take it into your naturalist toolkit. So here I'm going to use proportionality to figure out how many centimeters phi is going to be for my scale drawing, right? My unit is 1. I created a circle with radius 1 and then a square around it with radius 2. Now remember, I just picked a number. I was like, I want 1 to be 10 centimeters or 5 centimeters. Just pick something. And if you don't have a ruler, just like use a pen. Okay, my pen's going to be 1. So what do I multiply 1 by to get 1.618 times 1.618? So then I need to, just like writing equivalent fractions, proportionality works the same. I want to multiply 5 centimeters by the same factor so that I get an equivalent ratio. And I could spend time doing this out by hand. That's something you can do if you're interested in it. Otherwise, grab a device. I love my graphing calculator. Okay, so 5 times 1.618, 8.09. So I don't need to be that precise. I'm just human. So I'm going to round it to 8.1. So the height of my face of my pyramid net should be 8.1 centimeters. So it's going to go up to there, and I need to use my red marker. So hopefully you took that time to write a proportion and solve for whatever your unit is measuring in. If you are using a ruler, so 1 unit for me equals 5 centimeters. And I need to find the height of my face, which is going to be phi. And if I have phi as the value corresponding to the 1 unit, then I need to find the value corresponding to the centimeters. And I just do that by multiplying by 1.618. I get 8.1. So I'm going to go straight right angle. Make sure you're forming a right angle with the base of the triangle, and then you're going to draw a line. I'm drawing a line that's 8.1 centimeters tall. Okay, so the base of the face, that's the height of the face, right? That line is the height of the face of the triangle. I'm sorry, the face of the pyramid, which is a triangle. But this is also called the slant height of the pyramid. Okay, and what I want to show you is what that slant height is. So we have the height of the pyramid goes through the center of the pyramid, through the apex to that center point of the base. That's the height of the pyramid from here to here. Right? So if we closed one eye and thought of this three-dimensional pyramid as a two-dimensional picture, a flat, or if we took a cross-section, I love cross-sections. I can't wait to tell you guys more about cross-sections. But if we took a cross-section, the height of that would be the height of the pyramid. And we know that the height of the pyramid is the square root of phi. But the slant height of the pyramid is this, this angled height that hits the edge of the base, right, at a right angle and goes to the apex. That's the slant height, but it's also, when you unfold it and look at the surface area view of it, okay, that is the height of the base. And the face is a triangle, which also has its own base. So we have big capital B base, big base of the triangle of the square pyramid, and then we have lowercase b base, the base of the triangle. So lowercase b relates to the two-dimensional triangle. Uppercase b base represents the base of the three-dimensional solid. Okay, and then now, if this is phi and this is 1, then I should have my first face of my triangle. Now, I honestly just got to a moment where I'm like, did I do that right? So let's check, okay? And I don't think I did, because here I'm showing you guys that it's 1 squared plus the square root of phi squared equals phi squared. So 1 squared plus 1.618 squared is 3.617. And then what is phi squared? 1.618 squared. So it's because I need to do 1 plus 1.618 is 2.617. So this doesn't seem right. What did I do wrong? What did I do wrong? What did I do wrong? Did I do something wrong? You're like, Miss Lynn, I have no idea. That's fine. I didn't do anything wrong, because we have to talk about cross sections, okay? So this is why right triangles are really, really cool. The hypotenuse of the phi right triangle is this line, right? And that also forms a right angle inside. So the cross section is when you slice a three-dimensional solid and you look at the two-dimensional stamp that's created from it. And if we were to fold up this pyramid, okay, here's the center of the base. We have this angle, that's phi. That's the height of the face. So there's the face of the pyramid. See it? Okay. Now this distance is phi. That's this height. Okay. And then if we have the center of the base, okay, the apex is right above the center of the base of the triangle. That is the square root of phi. The height of the pyramid is the square root of phi, and then the distance from the center of the base to the edge of the base is 1, okay? But we have another right angle here, and drawing is a beautiful way to map math in your mind, because it forces you to take different physical, spatial perspectives versus me asking you all to take different emotional perspectives and conversations. This is a very straightforward, take a different spatial perspective. So using the Pythagorean theorem, just if you're curious about how long this line needs to be, just to show some of you who are interested, okay, I have the measurements of the two bases. So phi squared plus 1 squared equals this distance, that hypotenuse squared. So 1.618 squared, I just used my calculator, is 2.618. Okay? Oh, and we should know that because it's 1 plus 1.618. So see, like that was me just creating a neural pathway in my brain. Like that just solidified. I've been talking about it for a long time, but that moment solidified it in my mind. Okay, plus 1 equals c squared. So I have that 3.618 equals c squared. And this is where we use a square root to solve the equation. It's not addition, subtraction, our typical operators. It's a power. So I take the square root of both, and the square root of 3.618 is 1.9, about. Okay? So this distance is 1.9 units, which in my scale drawing, I have to multiply it by 1.618. Should be about well, I guess I'm not writing in centimeters here anyways, and I got messed up, right? So then if this is 1.9, then I need to multiply 1.9 by 5. Wrong. Yes. Right. Because 1 times 5 is 5, so 1.9 times 5 is 9.5. So this should be about 9.5 centimeters. So let's see if I'm right. Handy dandy. And it is! That's so cool. Okay, so this was just a tutorial. Yesterday we did a sketch of a net to start talking about how to think about phi in 3 dimensions. And now we did a much more precise approach of how to actually make a very precise model of the Pyramid of Giza. So you would repeat this process 3 more times. So you would come out phi, and then you form the isosceles triangle, the 2 right triangles. And now I'm just sketching because I want to respect your time. Okay, but those are all phi. These are all congruent faces because we have a square base. And then if I folded that up, it would be a model of the Pyramid of Giza. And these would be different size models, just a little bit. And I think it's powerful for you to have a collection of nets because just like any tool, they are the same shape but different sizes to fit a certain object. Like these are socket wrenches, so they are the same shape but different sizes. You might want to equip your toolkit with same shape, different sizes, proportional nets, because one net might fit this pine cone, right? But then it's not going to work very well for this pine cone, right? So think about it. I want you to equip your toolkits so that you can explore nature, okay? And as a quick closure, if you're still interested in some math, sweat, some brain sweat, let's take a look at this closure activity, okay? So a pyramid with a perpendicular slice, blah, 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 blah. We don't have time for all of that. How would you do the product of 6 and 36? How would you do the product of 6 and 36? 6 and 36. How would you do the product of 6 and 36? Well, I know 6 times 6 is 36. I know 3 times 6 is 18. Add a 0. 30 times 6 is 180 plus the 36. Well, plus 20 gets me to 200. And then I took 20 from the 36, so I have 16 left over. So 216? Is that how you did it? Can you do it another way? Can you do it 5 different ways? Can you draw a picture about it? Could you write a song about it? Could you rap about it? Day 16, rap. Thank you for tuning in. If you're live, if you're catching up with us on the recorded version of this, cheers to you. Way to show up. Get outside. Talk about math. Listen to others. I'm so proud of you. See you tomorrow, day 17.